Hello there, and welcome to the Drift to the Stars. I'm so glad you found your way here tonight. Whatever brought you here, whether it was a restless mind, a tired body, or simply the quiet pull of something larger than the day you just lived, you are welcome here. There is nothing you need to do, nowhere you need to be. Just this voice, and the dark, and a little bit of the universe to keep you company as you drift. And just before we begin, if these calm, curious explorations help you unwind, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Tonight we are going somewhere close enough to see with the naked eye on a clear night. A world that has been watching us as long as we have been watching it. A neighbor, a mystery, a mirror held up at a distance of 80 million kilometers, asking a question we are only just beginning to know how to answer. Now, if you're ready, let's begin. There is a planet not far from here, as space measures distance, where valleys wider than anything carved on Earth lie open under a pale, rust-colored sky. They are quiet now, bone dry, swept by winds that carry nothing but fine red dust. But if you could stand at the edge of one of those ancient valleys and simply look, you would notice something that stops the breath. The shape of the land is wrong for a desert. It is too smooth in the wrong places, too curved, too wide at the base. The walls have the warm, gentle look of stone that was touched by something slow and patient for a very long time. What touched it was water, rivers of it. Not a flash flood, not a brief season of ice melt, but flowing water, settling into channels, wearing stone down over thousands of years the way a river wears the banks of a valley here on Earth. Mars was once warm enough that liquid water pooled in valleys wider than anything on Earth today. Scientists can read this in the shape of the land itself, in the minerals left behind, in the rounded edges of ancient stone. The universe does not always announce its past in fire. Sometimes it leaves it in the quiet curve of a riverbed, waiting for something curious enough to come and notice. You are lying still right now, or nearly still. You are breathing slowly. You feel, perhaps, like the smallest thing in a very large night. And in one sense, that is exactly what you are. But in another sense, what you are is ancient beyond any comfortable measure. The atoms moving through you at this moment, the carbon in your cells, the oxygen crossing your lungs, the iron carrying a quiet pulse through your blood, none of them were made here. None of them were made on Earth. They were forged inside stars that burned and died before the sun existed, before this solar system was anything more than a slow spiral of gas and dust, before Mars was a planet or Earth was a thought. Your body contains atoms older than the solar system itself. This is not a poetic way of saying something vague. It is a measured, verified fact of nuclear physics and stellar chemistry. Right now, as you rest, you are carrying the ash of ancient stars. You are not separate from the cosmos looking up at it. You are made of it, resting quietly inside it, the way a wave is made of the ocean it moves through, somewhere on Mars, rising so slowly from the plains that you would walk toward it for days before you truly understood what you were approaching. There is a mountain. It does not look like a mountain from far away. It is too wide, too gradual. It spreads across the land the way a sleeping giant might spread beneath a blanket, enormous not in sharpness, but in sheer, unhurried mass. Olympus Mons is the tallest volcano in the solar system. Its peak reaches so high above the Martian surface that it rises above most of the planet's own atmosphere. The air at its summit is even thinner than the air at its base, which is already far thinner than the top of Mount Everest. It formed because Mars, unlike Earth, has no moving tectonic plates. On Earth, a volcanic hotspot slowly builds a chain of islands as the crust drifts over it. On Mars, the crust stayed still, and the lava kept coming, piling up in the same place for hundreds of millions of years. There is something quietly humbling in that. Not all greatness is built in a rush. Some of the largest things in the solar system grew simply because nothing moved them along. Stand at the edge of any ocean on Earth and let the size of it settle into you. The Pacific alone covers more of this planet than all the land combined. It is almost impossible to hold in the mind as a single thing. It feels, from any shore, essentially infinite. And yet, scientists now believe that Mars was once covered across its entire northern hemisphere by an ocean. An ancient sea, shallow in some places, deeper in others, stretching from horizon to horizon across a world we once thought of as simply a dry, red desert. Earth's oceans, vast as they feel from shore, would fill only a fraction of the ancient Martian sea that researchers believe once covered the northern hemisphere. The evidence lives in the landscape. Ancient shorelines, mineral deposits that only form in standing water, a vast lowland basin shaped by something that filled it for a very long time. We did not know this 40 years ago. We are only beginning to know it now, and there is something gently staggering in the idea that the universe hid an ocean on another planet, and we found it not by sailing to it, but by reading the shape of the land from orbit. This one arrives like a small gift. Of all the planets circling our sun, only one other spins at a pace that would feel almost familiar to you. Not Venus, which takes longer to rotate than it takes to orbit the sun. Not Jupiter, which spins so fast a day there lasts less than 10 hours. Not Saturn, not Uranus, not Neptune. Mars. A Martian day is only 37 minutes longer than your own. You would wake on Mars, watch the sun rise in a butterscotch sky, and by the time it set, only a little more time would have passed than a full day here. This small coincidence has practical meaning for the scientists and engineers who operate rovers on the surface. They live on Martian time during missions, shifting their schedules by 37 minutes each day, slowly drifting out of sync with everyone else on Earth. In the vastness of the solar system, among all the planets spinning at all their different speeds, the one most like yours belongs to our nearest neighbor. The universe, just occasionally, arranges things with a gentleness that feels almost like intention. Beneath the south pole of Mars, buried under layers of ice and dust so thick and cold they press down like the weight of a slow century, there is something that should not be there, something the surface gives no hint of, something that only revealed itself when a radar instrument aboard a spacecraft sent pulses of radio waves straight down through the ice and waited to see what came back. What came back was a signal that matched almost exactly the signature of liquid water. Radar signals beneath the Martian South Pole hint at a buried lake, roughly 20 kilometers across, that has likely never seen sunlight. The cold is so extreme at that depth that the water stays liquid only because of dissolved salts lowering its freezing point, and possibly because of trace geothermal heat rising from below. Scientists are still debating its exact nature. They are careful, as good scientists are, not to claim more than the data shows. But somewhere beneath all that quiet ice, something liquid may be sitting in the dark, very still, very cold, in a silence that has lasted for millions of years. There is a moment when you look at an old iron gate, the kind that stands at the entrance of a garden that has been there longer than anyone living can remember, and you notice the color. Not brown, exactly, not orange. Something richer and older than either, a deep, settled red that spreads slowly across the surface of the metal, turning it soft and warm with age. That color, that exact quiet chemical process, is why Mars is red. The surface of Mars is covered in iron oxide, which is simply iron that has reacted with oxygen over billions of years. Rust, in the most elemental sense of the word. The same patient chemistry that softens old iron gates in rainy gardens colored an entire planet. The red color of Mars is rust. There is nothing more to it than that, and there is nothing less. It is the most ancient, ordinary transformation of iron meeting oxygen, written across a world at a scale so large it is visible from Earth with the naked eye. Some of the most extraordinary things in the universe are made of the most familiar ingredients. The strangeness is only in the size. You cannot see it, you cannot feel it, but there is something wrapped around you right now, something generated deep inside this planet, flowing outward through the rock and into the space above your head, and extending far beyond the atmosphere into the dark. Earth's magnetic field, invisible, vast, and quietly essential to everything alive here. Mars once had one too. Billions of years ago, Mars had a magnetic field strong enough to wrap the planet in a protective shield, deflecting the charged particles streaming outward from the sun, holding the atmosphere close to the surface the way Earth's field holds ours now. Then something happened. Scientists believe the planet's interior cooled faster than Earth's. The churning of molten rock slowed, and the field weakened. Over hundreds of millions of years, it faded. Without it, the solar wind began to strip the atmosphere away, particle by particle, year by year, across an immensity of time. You are being protected right now by something you will never see. Mars was not, and slowly, gently, over a period longer than life has existed on Earth, it lost the conditions that made it something like a home. On Earth, the sky earns its blue during the day, scattering short wavelengths of sunlight across the atmosphere from horizon to horizon. And then at evening, it surrenders that blue and lets the longer, warmer wavelengths flood in, turning the horizon gold, then amber, then a deep and settling red. Mars does this in reverse. At sunset on Mars, the sky near the sun turns a soft, quiet blue, while the rest of the sky holds its daytime rust and amber. The dust particles suspended in the thin Martian atmosphere scatter light in the opposite way from Earth's air, letting the blue wavelengths linger near the horizon at the end of the day, while the rest of the sky fades through pink and brown. The Martian sky at sunset turns a soft shade of blue, the exact inverse of what happens here. This has been confirmed by cameras on the surface, photographs taken by machines we sent across the solar system and landed gently on another world. No human eye has seen this in person. Not yet. Somewhere in the future, perhaps not very far, someone will stand on that surface as the sun descends, and they will watch a blue sunset fall over a red desert, and they will know they are the first. Somewhere on the surface of Mars right now, a machine the size of a small car is parked in the dark. It has been there since 2012. It woke this morning, ran its instruments, took measurements of the air and the rock and the radiation, and sent its findings across hundreds of millions of kilometers to a dish antenna on Earth, where someone was waiting. The Curiosity rover has been slowly climbing a layered mountain called Mount Sharp since it landed, reading the geology of Mars the way a scientist reads the pages of a very old, very patient book. Its journey has taken longer than some children have been alive. It is still going. There is something deeply restful in that image, if you let it settle. A machine, built by human hands, driven by human curiosity, moving at the pace of a slow afternoon walk across a world where no human has ever stood, sending postcards home to people who will never visit the place the photographs show. We are, as a species, capable of extraordinary patience when something matters enough to us. The universe rewards that patience, not always with answers, but sometimes with better questions. If you lifted Valles Marineris from the surface of Mars and set it down across the middle of the United States, its western end would rest somewhere near Los Angeles. Its eastern end would reach past New York and out over the Atlantic Ocean. It is not a canyon in the way the Grand Canyon is a canyon. It is a system of canyons, vast interconnected rifts and gorges and collapsed regions, some of them nearly 7 kilometers deep, wider in places than the entire state of Texas. Mars carries a canyon so deep and wide that placed on Earth it would stretch from one coast to the other. It began as a crack, a seam in the crust that formed as the Tharsis volcanic region swelled and pushed the surrounding land apart over billions of years. Slowly, quietly, through collapse and erosion and the slow, patient work of geological time, it became the largest canyon in the solar system. There is nothing violent in how it formed, only time and pressure and the slow release of forces that had been building for longer than life has existed anywhere we know of. Some things grow large simply by being given enough time to do so. The ground beneath your feet has been underwater. If you could watch a single point of land on Earth across the full span of geological time, you would see it submerged beneath shallow seas, lifted into mountains, worn flat, flooded again, dried again, folded and cracked and smoothed over timescales. So long, the word ancient barely reaches them. Every continent has been underwater more than once in deep time. The limestone in the walls of old buildings was once seafloor. The chalk in white cliffs is the compressed remains of tiny marine creatures that lived in a sea that no longer exists. The ground itself is a record of change, so total and so slow it looks, on the surface, like permanence. This is worth holding gently when you think about Mars. A planet changing, drying, losing its seas and air over billions of years is not an anomaly. It is what planets do. It is what Earth has done, in different ways, across its own long life. Change at this scale is not a crisis. It is simply time, moving at the pace time moves when nothing is watching. The two small moons of Mars are not what you might imagine when you hear the word moon. They are not round. They are not silver. They do not rise full and slow over a dark horizon the way ours does on a clear night. Phobos and Deimos are dark, irregular, lumpy little worlds, shaped roughly like misshapen potatoes, each one so small that if you stood on the surface of the larger one, Phobos, the horizon would curve away from you in minutes of walking. They look, to every instrument that has studied them, like captured asteroids, ancient rocky wanderers that drifted too close to Mars long ago and never left. Mars has two moons so small and dark they tumble through their orbits more like hitchhikers than companions, and Phobos is slowly falling. Every year, it drifts a few centimeters closer to the planet. In perhaps 50 million years, it will either break apart into a ring or spiral down to the surface. Right now, somewhere in the Martian sky, Phobos rises and sets twice in a single day, moving so fast across the sky that you could watch it travel from horizon to horizon in just a few hours. A small, dark moon in a hurry toward an ending still millions of years away. There is a kind of beauty that belongs entirely to impermanence. The frost on a winter window, a breath visible in cold air, a thin skin of ice over a puddle that will be gone before noon. Mars has this kind of beauty too. On certain Martian mornings, frost forms across the ground, a pale and delicate coating that settles in the lowest points of the terrain during the night, and then, as the sun climbs and the temperature shifts, quietly disappears. It vanishes within hours, sometimes within minutes in sun-warmed spots, leaving the ground exactly as it was before, as if nothing had visited. This frost is not ice, in the way a frozen lake is ice. It is thin, fragile, and in many regions made partly of frozen carbon dioxide, the same gas you exhale with every breath. But in some places, near the poles and at higher latitudes, it is water frost, real water, briefly solid on the surface of another world, catching the pale Martian sunlight before the day takes it back. The universe makes delicate things in cold places. You just have to be paying attention at the right hour. The coldest temperature ever recorded on the surface of the Earth was measured in Antarctica, at a station called Vostok, during the long polar winter. It was cold enough to freeze exposed skin in seconds, cold enough to make the air feel solid, cold enough to sit in the mind as a kind of limit. On Mars, that temperature would be considered a warm afternoon. The average temperature across the Martian surface is around -60 degrees Celsius, colder than any night ever recorded anywhere on Earth. And that is the average, not the extreme. Near the poles in winter, temperatures fall far lower. Even at the equator, once the sun sets, the ground loses heat so quickly in the thin air that temperatures can drop by 60 degrees in a matter of hours. And yet Mars was not always this cold. The minerals and the landforms and the chemistry of its ancient rocks all point to a time when temperatures were mild enough for water to move freely across the surface, when the air was thicker and warmer and the sun, smaller in the Martian sky, was still enough. What was once warm can become cold over time. This is not a tragedy. It is a fact, held gently, about the long patience of the universe. There are places on Mars where the ground is carved into shapes that make no geological sense without water. Not the subtle shapes, not the ambiguous ones. Shapes that are unmistakable. Wide, branching channels that narrow as they climb toward higher ground, exactly the way a river system narrows from its mouth toward its source. Scientists have found dried riverbeds on Mars that only make sense if water flowed through them for thousands of years, not days or seasons. The channels are too wide, too smooth, too well developed to be the work of a brief event. They required time, sustained flow, a climate that permitted liquid water to exist long enough to do the patient, unhurried work of carving stone. These are not theoretical features. They have been photographed from orbit, studied from the surface, measured and analyzed and debated and confirmed. They are there, waiting in the rock, exactly as rivers leave their signatures in the rock of any ancient valley on Earth. Water, it turns out, writes the same way everywhere it goes, and once you know how to read that handwriting, you begin to see it written across an entire planet. Think of the ice cores that scientists drill from the deep heart of Antarctica or Greenland, pulling up cylinders of compressed snow that fell thousands of years ago, each layer a year, each tiny trapped bubble a sample of air from a world that no longer exists. Reading them is like reading a diary written in ice, one quiet season at a time. Mars keeps its diary the same way. The Martian polar ice caps are built in layers, ice and dust pressed together in alternating bands, each one recording a season that passed millions of years ago. The thickness of each layer holds information about how much dust was in the air, how cold the winter was, how long the summer lasted. Scientists can read climate cycles in those layers that stretch back further than our species has existed. Both poles carry this record, north and south, patient and undisturbed, waiting in the cold for instruments sensitive enough to read them. There is something quietly moving in the idea of a planet that has been keeping its own history, in its own way, in its own time, with no one to read it for 4 billion years. Until now, somewhere in Antarctica, long before any human thought to look for it, a rock was lying in the ice. It had been there for 13,000 years. Before that, it had traveled through space for millions of years. And before that, it had been part of the surface of Mars, blasted free by the impact of an asteroid, and sent drifting slowly through the solar system until Earth's gravity pulled it home. That rock, catalogued as ALH 84001, was found in 1984 by a team of scientists walking the Allen Hills ice field. It sat in a laboratory for years before anyone understood what it was. When they did, a careful and cautious study of its interior found tiny structures that some scientists believed might, possibly, perhaps, be the fossilized remains of ancient microbial life. A meteorite from Mars rested quietly in Antarctica for thousands of years before a human hand ever touched it. The debate about what those tiny structures mean has never been fully resolved. Most scientists today believe they formed through chemistry rather than biology, but the question was asked. And once a question like that is asked carefully, honestly, with evidence in hand, it does not go away. It waits, the way the rock waited, for the tools and the knowledge that will one day be enough to answer it. There are days on Earth, usually in late summer in certain desert regions, when a dust storm begins small and builds, a brown haze on the horizon, a dimming of the afternoon light, dust settling on every surface by evening, a fine coating over everything, the world slightly muted, slightly amber. Now imagine that storm growing. Imagine it spreading not across a county, not across a continent, but across an entire planet. Imagine it lasting not for a day or a week, but for months, swallowing every feature, every canyon, every mountain, every plain, until the entire world is wrapped in a dim, swirling veil of iron-red dust. Mars has dust storms capable of engulfing the entire planet, turning day into a strange amber twilight that can last for months at a time. The storm that ended the Opportunity rover's mission in 2018 was one of these. The solar panels were buried in dust and darkness, and after 15 years of patient exploration, the rover fell silent. Scientists still send the occasional signal, just in case. There has been no answer. But the rover is still there, somewhere on the Martian plain, dusted over and quiet, having traveled further across that world than anyone dared hope when it landed. If you picked up a smooth, rounded river pebble from a streambed anywhere on Earth and held it in your hand, you would be holding a record of motion. That shape, that smooth and satisfying roundness, was made by the pebble tumbling against other stones in moving water, its edges worn away slowly, its corners softened by the patient friction of a current that carried it downstream over years or decades. The Curiosity rover found pebbles like that on Mars, rounded, smooth, the right size and the right shape to have been carried and tumbled by a river, flowing at a walking pace across an ancient Martian streambed. The chemistry of the ancient Martian rocks in these regions suggests that rivers there were not harsh or acidic, but gentle, possibly life-friendly waters, calm enough and chemically mild enough that if life had found a way to begin, these rivers would not have been hostile to it. The rock held in a rover's camera, 400 million kilometers away, has the same smooth, comfortable shape as a pebble from a stream in any quiet valley on Earth. Water writes the same story everywhere. The handwriting is identical. Hold your breath for a moment and notice what happens. Not for long, just a few seconds. Notice the very specific animal urgency that builds. That feeling, that pressure, that rising insistence from somewhere deeper than thought, is your body reminding you of something it has never forgotten, even for a second, since you were born. You need air, a particular kind of air shaped, over billions of years, by the same geological and biological forces that shaped this planet. You are breathing air whose composition was partly determined by volcanic activity. The nitrogen, the oxygen, the trace gases cycling through your lungs right now were all, at various points in deep history, processed through the interior of this planet and released into the atmosphere through eruptions and venting and the slow chemical work of rock meeting air. Mars once had volcanic activity that released similar gases, thickening its early atmosphere. The same basic chemistry, the same planetary breathing. The difference is that Earth kept it, held it, renewed it continuously, while Mars, losing its magnetic shield, could not hold what its volcanoes gave. You are breathing the lucky outcome of a planet that managed to hold on. That is not nothing. There is a quality to mornings in early spring in certain places, a particular cool softness in the air, a sense that the world is not fully awake yet, that the day is still deciding what it will be. The light is gentle. The temperature is mild. It does not feel like summer, and it does not feel like winter, and for a brief hour it feels almost perfectly balanced. The Martian equator, on the warmest afternoons of the longest summer days, can briefly reach temperatures close to that, a cool, mild afternoon. Not warm exactly, but not the deep cold of space either. Temperatures have been recorded near the equator in Martian summer that sit close to what you might feel on a cool spring day, perhaps around 20 degrees Celsius, in the most favorable conditions. And then the sun sets, and the thin air, unable to hold its warmth, the way Earth's thicker atmosphere holds heat through the night, surrenders every degree it gained during the day. Within hours, the same ground that briefly felt almost welcoming drops to temperatures far below any winter night you have ever known. Mars does not hold warmth the way Earth does. What it gains in a day, it loses before morning. There is something in that worth sitting with quietly, without needing to name it. Scientists are genuinely uncertain whether life ever arose on Mars. Not uncertain in the way that suggests carelessness, or that the question has been overlooked. Uncertain in the careful, honest way of people who have looked very closely, gathered every piece of evidence they can reach, and found that the evidence is not yet enough to say yes or no with confidence. This is not a failure of science. It is science doing exactly what it is supposed to do. What is known is this: Mars had liquid water. It had a source of chemical energy. It had organic molecules, the building blocks of life as we know it. It had, for a period of perhaps hundreds of millions of years, conditions that on Earth would have been considered hospitable to microbial life. Whether life actually arose in those conditions is the question that remains open. That open door is one of the most extraordinary things in science right now. Not a mystery born of ignorance, but one born of genuine, careful investigation that has arrived at the edge of what we currently know and stopped there, honestly, without pretending. The universe keeps some of its answers in places we have not yet reached. That is not a frustration, it is an invitation. There is a basin in the northern hemisphere of Mars, so vast and so low that when scientists first began to understand its scale, they had to reconsider what they thought they knew about the planet's history. Hellas Planitia, the largest confirmed impact crater on Mars, is deep enough and wide enough that if filled with water, it would form an inland sea larger than the Mediterranean. But it is the northern lowlands as a whole, that enormous low-lying region covering the upper third of the planet, that carries the most compelling signs of an ancient ocean. The largest impact basin on Mars is so wide it may once have been cradled by ancient shorelines, the edge of a sea that covered a third of the planet. Mineral deposits consistent with long-standing water, ancient beach-like terraces running at consistent elevations for thousands of kilometers, a landscape shaped by the slow settling of sediment in still water. The ocean did not announce itself. It left its evidence quietly in the rock, in the chemistry, in the shape of the land. Oceans always do. Even as you rest right now, your heart is keeping a rhythm you did not choose and cannot stop. It has been beating since before you were born. Somewhere between 60 and 100 times each minute, a quiet percussion running beneath everything you have ever thought or felt or done. Across the solar system, on a dusty plain in the ancient southern highlands of Mars, the Curiosity rover runs its daily cycle of measurements. Its instruments tick through their routines at intervals set by engineers on Earth. The timing of those cycles, the rhythm of its daily work, moves at a pace not entirely unlike the rhythm of a resting heartbeat. Your pulse and a rover's daily routine, separated by hundreds of millions of kilometers of cold vacuum, both keeping time in their own way, both expressions of something careful and sustained and quietly alive to the world around them. There is no grand meaning in that parallel, only the small, unexpected comfort of recognizing that rhythm is everywhere, that the universe, at every scale, seems to prefer things that keep going. Seasons arrive on Earth with a kind of reliable drama. The angle of light shifts. The air changes its character. Leaves do what leaves do. You feel it in your body before you see it on a calendar. A subtle internal awareness that the year is turning, that time is moving in its familiar circle. Mars has seasons too. The same tilted axis, the same logic of a planet leaning toward and away from its sun as it travels its orbit. Spring, summer, autumn, winter, all four, in order, year after year. Mars has seasons just as you do, though each one lasts nearly twice as long as a season on Earth. A Martian year is almost 2 Earth years, meaning a Martian winter is not a few months of cold and bare trees, but a long, slow, half-year settling into deep cold, followed by an equally gradual, patient return of warmth. The rovers experience these seasons. The dust in the air changes, the frost patterns shift, the length of the day grows and shrinks. A planet with seasons is, in some fundamental way, a planet with a kind of rhythm. And rhythm, wherever it appears, feels like something we recognize. There is a particular quality to very old stone. Not old in the way a building is old, or even old in the way a mountain range is old. Old in a way that sits outside the comfortable edges of imagination. A stillness in it that is not emptiness, but depth. A sense that the stone has been here through so many changes that it has simply stopped registering them. The heavily cratered southern highlands of Mars carry that quality in every image ever taken of them. The ancient Martian southern highlands are so densely cratered they preserve a record of a period called the Late Heavy Bombardment, a time roughly 4 billion years ago when the inner solar system was being struck repeatedly by asteroids and comets in a relentless, slow catastrophe that lasted hundreds of millions of years. That period ended, the solar system settled, the craters on Mars remained, undisturbed, unrecycled, unerased by the plate tectonics and erosion that have wiped most of Earth's equivalent record away. Mars kept the memory. Earth let it go. Between the two of them, we begin to understand what the early solar system actually looked like. On a clear night, far from city lights, if you know where to look, you can find it without any instrument at all. A faint reddish point of light, steady where the stars twinkle, moving slowly against the background of the sky over the course of nights and weeks. Mars, visible to the naked eye, has been watched by human beings for as long as human beings have been watching the sky. Ancient Egyptians tracked its movements. Babylonian astronomers recorded its position on clay tablets. Every culture that ever looked up found it and noticed it and wondered about it. They named it after gods of war for its color, its redness, the way it seemed to pulse like an ember among cooler stars. None of them knew what it was. None of them knew it was a world. None of them knew it had mountains and canyons and polar ice caps and ancient riverbeds. They saw only the light. You are seeing, when you look at Mars, the same light those ancient watchers saw, arriving in your eye from the same source, crossing the same darkness. The only difference is, what you now know is at the other end. Place a glass of water on a table on the summit of a very high mountain and watch what happens. At high enough altitude, where the air pressure is low enough, the water will begin to boil at a temperature far below what it boils at sea level. Reduce the pressure further still, and the boiling point drops lower and lower, until at a certain point water cannot exist as a liquid at all. It passes directly from solid to vapor, skipping the liquid state entirely. The atmospheric pressure on Mars today is less than 1% of Earth's sea level pressure. At that pressure, it would simultaneously boil and freeze, the two processes competing in a fraction of a second, the water gone before it could settle. This is why Mars cannot have stable liquid water on its surface today, despite the fact that water ice is plentiful. The air is simply too thin to let it exist in liquid form. It requires either a thick atmosphere, which Mars once had and lost, or a layer of something above it, like ice, to hold the pressure high enough. The absence is not permanent. It is conditional, and conditions, as Mars itself demonstrates across its long history, can change. There is a kind of trust involved in turning on a lamp in a dark room. You do not think about it. The electricity moves through the wire, and the bulb responds, and the darkness retreats, and it is simply what happens. The physics is invisible, automatic, underneath everything. Solar panels work on Mars. The same relationship between sunlight and silicon that powers a calculator on a desk or a panel on a rooftop works across the distance between Earth and Mars, on a world where the sun is smaller in the sky and the light arrives slightly cooler and more diffuse. The rover Opportunity ran on solar power for 15 years. The Ingenuity helicopter, the first powered aircraft ever flown on another planet, lifted itself into the Martian air on electricity gathered from sunlight. Despite its cold and thin air, Mars receives enough sunlight that solar panels function there. The same quiet physics that warms your windowsill stretched across 80 million kilometers without losing its essential nature. The laws of physics do not change at the edge of the solar system. They do not change anywhere. You are held by the same rules that govern every grain of Martian dust, every orbit, every atom in the universe. That sameness is not a constraint. It is the deepest form of connection there is. There are dark streaks on the steep inner walls of certain Martian canyons and craters. They appear in the warm season and fade in the cold. They run downhill in the way that flowing liquid runs downhill. They look, from orbit, like something wet moving slowly down a slope. Scientists call them recurring slope lineae. They have been studied carefully, debated carefully, and the conclusion has been careful too. Almost certainly not flowing water in the way a stream flows, but possibly briny, salty seeps, water so laden with dissolved salts that it remains liquid at temperatures where pure water would freeze, moving slowly through the surface material and darkening it before evaporating. Mars has features on its canyon walls that appear and disappear with the seasons, and scientists are still working to understand exactly what they are. The most recent research suggests they may be dry, granular flows, dust avalanches triggered by seasonal temperature changes rather than liquid water at all. The uncertainty is real, the investigation is ongoing, and there is something genuinely restful in a science that says, clearly and without embarrassment, we are not sure yet. We are still looking. A human body on Mars would weigh less than half of what it weighs on Earth. Gravity on Mars is roughly 38% of what it is here. Every step would require a conscious recalibration. The muscles built for this planet would find themselves absurdly overpowered, sending a person bounding upward with the effort of a normal stride. Astronauts returning from long stays on the International Space Station, where gravity is essentially absent, described the return to Earth as a sudden, almost shocking heaviness. Everything that had felt weightless becomes demanding again. Water pouring from a tap feels aggressive. Standing requires effort. A human on Mars would move through each step with an unfamiliar, dreamlike lightness, their body carrying the muscle and bone density built for a heavier world into a place where that weight is more than enough. Early Mars explorers would walk carefully, precisely, learning the new logic of a body in weaker gravity. What you carry right now, the weight of your body against whatever surface is holding you, is a very specific relationship between you and this particular planet. It belongs here. It was built here. It is, in its quiet way, a kind of intimacy. Dig down just a few centimeters beneath the surface of Mars in the right latitude, and you would find it. Not deep, not buried in some remote and unreachable place. Just beneath the thin, rust-colored skin of the planet, in regions stretching across vast areas of the mid and high latitudes. Water ice exists right now, today, close enough to the surface that a future astronaut with a simple shovel could reach it in minutes. Water ice exists on Mars right now, locked in polar caps and buried just beneath the surface in many regions across the planet. Instruments aboard orbiting spacecraft have mapped its distribution with increasing precision, finding it widespread, finding it accessible, finding it in quantities that have shifted how scientists think about the possibility of future human presence there. This is not ancient ice locked in deep rock. In some places, it is geologically young, deposited during recent shifts in the planet's axial tilt, when the climate was cold enough to let it accumulate near the surface. It is the most immediately accessible resource on another world that humans have ever identified. The ice is there, quietly, waiting in the cold dark just below the surface of a planet we have been watching since before we had writing, patient in the way that only very cold things can be patient. Most things in the solar system spin with an axis that wobbles only slightly over time, a small, stable variation that produces gentle, predictable climate cycles. Earth's axial tilt shifts between roughly 22 and 25 degrees over a cycle of about 40,000 years, and this modest wobble is enough to drive the ice ages that have shaped the history of life on this planet. Mars wobbles far more dramatically. Without a large moon to stabilize it, the way our moon stabilizes Earth's tilt, Mars can shift its axial tilt between nearly 0 degrees and over 60 degrees over millions of years. At 0 degrees, the poles receive almost no seasonal variation, and ice accumulates there year-round. At high tilt, the poles receive intense seasonal sunlight, ice sublimates, the atmosphere thickens, and the climate shifts into something almost. Mars spins on an axis that wobbles far more dramatically than Earth's over millions of years, reshaping its climate in slow, sweeping cycles. This means Mars has experienced radically different climate states across its history. and some of those states may have been briefly warmer and wetter than anything in the planet's recent memory. Our moon is, in a quiet and underappreciated way, one of the reasons life had a stable enough climate on Earth to develop over billions of years. The moon has been holding us steady. We have not always known to be grateful for that. There is a particular kind of endurance that belongs not to speed or strength, but to consistency. The kind that belongs to a river wearing a canyon, or a tide shaping a coastline, or a small machine rolling slowly across a distant plain, day after day, year after year, in a silence no human ear has ever heard. The Opportunity rover landed on Mars in January 2004 with an expected mission of 90 days. It drove for nearly 15 years. By the time the global dust storm of 2018 ended its mission, it had covered a distance greater than a marathon, more than 45 kilometers, across the surface of another world, one careful meter at a time. The rover Opportunity drove farther across Mars than a marathon distance, over the course of 11 quiet years, exploring craters, studying rocks, finding evidence of ancient water, and sending home thousands of images of a landscape no human eye had ever seen directly. When contact was finally lost, mission controllers sent one last signal. They attached to it a song, Billie Holiday singing, "I'll Be Seeing You," in all the old familiar places. The rover did not respond, but somewhere on the Martian plain, in the dust and the silence, it is still there. On certain cold mornings in high mountain regions, if the air is still and the temperature dropped sharply overnight, you might look up and see something strange and beautiful. Thin, wispy clouds drifting over the peaks, made not of rain but of ice crystals, catching the early light in ways that make them almost luminous. Mars has clouds like this too. Thin, wispy water ice clouds drift across the Martian sky, forming particularly near the great volcanoes on cold afternoons, when rising air currents carry moisture upward into the cold upper atmosphere, where it freezes into tiny, drifting crystals. Images from both orbiters and surface rovers have captured them, pale and delicate, against the butterscotch Martian sky. They are not the dramatic, towering clouds of an Earth thunderstorm. They are quiet things, thin as breath, forming in the cold air above ancient volcanic slopes and drifting slowly downwind before the day warms enough to dissolve them back into the air. A planet with clouds is a planet with weather, and a planet with weather is, however subtly, a planet that is still alive in some of the ways that matter most. There is a way of reading stone that geologists develop over years of careful practice, a kind of fluency in the language of rock, where color and texture and layering and chemistry all speak at once about conditions that existed long before any living thing was present to observe them. It is a slow language, patient, requiring more attention than most things in modern life allow. The chemical fingerprint of water is locked into Martian minerals across vast regions of the planet. Phyllosilicates, clay minerals that can only form in the sustained presence of liquid water. Sulfates, deposited by water evaporating slowly from ancient lakes. Carbonates, formed when water reacts with carbon dioxide over long periods of time. Each one a word in the same sentence. Each one saying the same thing in a slightly different way. Water was here, not briefly, not accidentally. It was here long enough to change the chemistry of the rock, to leave its signature in the mineral structure of the planet itself, a record so durable it has survived 4 billion years of cold and wind and radiation without being erased. Stone remembers what air forgets. Mars has been keeping this record the whole time. Think about what it would mean for a planet to have no moving crust, no plates slowly grinding against each other, no continents drifting apart, no ocean floors being pulled down into the mantle and reborn as new volcanic rock, no recycling, no renewal, no geological metabolism. Mars has no plate tectonics. Its surface is, in the most literal sense, a memory. Whatever formed on the surface of Mars has largely stayed where it formed. Ancient craters remain. Ancient riverbeds remain. Ancient lava flows remain. The planet has not turned itself over and started again, the way Earth continuously turns itself over and starts again. Mars has no plate tectonics, meaning its surface is a memory, nothing recycled, nothing erased, for billions of years. This makes Mars an extraordinary archive. Where Earth has destroyed most of its own early history through geological renewal, Mars preserved it, sitting in the cold and the dark with its 4 billion-year record intact, waiting for instruments sensitive enough to read it. We cannot read our own planet's earliest chapters. They have been consumed and rewritten too many times, but we can read them on Mars. Our neighbor has been keeping the pages we lost. Stand in a desert on a still day and watch the sand. Nothing seems to be moving. The dunes appear fixed, permanent, as solid as any landscape feature you might walk across. But over days and weeks and years, the dunes are moving, grain by grain, lifted by wind and deposited slightly downwind. The entire dune migrates slowly across the desert floor, leaving no trace of where it was. The wind on Mars carries meaning. It sculpts dunes into shapes that scientists can read like a language, using the direction of dune crests and the patterns of ripples on their surfaces to reconstruct the history of Martian winds, the prevailing directions and seasonal shifts of air currents that have been flowing across the planet for millions of years. Some Martian dunes are dark, made of volcanic basalt sand, and they move measurably from year to year in images taken by orbiting cameras. Others appear to be locked in place by surface crusting, frozen mid-migration, a snapshot of a wind pattern from a climate that no longer quite exists. Wind is the breath of a planet with an atmosphere. Mars is still breathing, slowly, thinly, but breathing. And in every dune and ripple and dust devil crossing the afternoon plain, it is still writing its slow, patient record of that breath. Somewhere on Earth tonight, a child has been born who will, if current plans and timelines hold, live to see humans walk on Mars. The first crewed Mars missions are being planned now, with serious engineering and serious funding, and serious people spending their working lives on the problem of how to keep human beings alive on another planet. The first human to stand on Mars may already have been born. They may be in school right now. They may be learning to read. They may be asleep somewhere on this same planet, under the same stars, with no idea yet what their life will one day contain. That person will look up at a blue sunset over a red desert and breathe recycled air from a system the size of a backpack, and they will be the first human being in 4.5 billion years of this solar system's history to stand on a world other than the one where all of their ancestors lived and died. There is something about that which belongs less to the future than to right now. The first footstep on Mars is already in motion. It is being built toward, slowly, carefully, one mission at a time. Volcanoes on Earth are dramatic, visible, immediate. They announce themselves with ash columns and lava flows and tremors that shake the ground for miles in every direction. They are events. They have beginnings and endings. The eruption at Krakatoa lasted days. The one at Mount St. Helens lasted hours for its most violent phase. Even the longest sustained eruptions in recorded human history measure in years, not millennia. Volcanic eruptions on Mars may have released enough gas to temporarily warm and thicken the atmosphere, creating brief windows lasting perhaps tens of thousands of years when liquid water could exist on the surface. The eruptions that built Olympus Mons and the Tharsis volcanic plateau were not events in any human sense of the word. They were geological epochs, sustained outpourings of lava and gas lasting hundreds of millions of years, slowly building the largest volcanic structures in the solar system, while simultaneously exhaling carbon dioxide and water vapor and sulfur dioxide into the thin Martian sky. These eruptions may have periodically revived the atmosphere enough to allow rivers to flow and lakes to fill, brief warm intervals in a long cooling story, like embers flaring occasionally in a fire that is slowly going out. The universe works on timescales that make human patience feel like a brief held breath. And sometimes, In that vastness of time, conditions align just long enough for something remarkable to almost happen. When you look at Mars tonight, if the sky is clear and you know where to find it, the light entering your eye left that planet somewhere between 3 and 22 minutes ago, depending on where the two planets currently sit in their orbits. You are not seeing Mars as it is. You are seeing Mars as it was. This is true of everything you see in the sky. The moon as it was just over a second ago. The sun as it was 8 minutes ago. The nearest star as it was 4 years ago. The most distant galaxies as they were billions of years ago, so far back that the universe was a fundamentally different place when that light began its journey. The light reaching your eye when you look at Mars left that planet several minutes ago, so you are always seeing it as it was, never quite as it is. There is no way to see the present state of anything beyond your immediate reach. Distance is delay. Looking outward is always, unavoidably, looking backward in time. You are a creature living in a permanent, gentle past when it comes to the universe. Everything you see in the night sky is a message that has already traveled a very long way to reach you. The sky is not the present. It is a museum of light, and every point in it is a different age. Deep beneath the surface of certain volcanically active regions on Earth, heat from the planet's interior radiates upward through the rock, warming groundwater, sustaining ecosystems in places that sunlight never reaches. The hydrothermal vents on the ocean floor are the most dramatic expression of this. Entire communities of life built entirely on chemical energy from the Earth's interior, with no connection to sunlight whatsoever. Mars may still hold something like this, quietly, in limited regions. Beneath certain Martian volcanic regions, the ground may still retain geothermal heat, a faint warmth left over from the planet's younger, more volcanically active years. Some researchers believe this residual heat could, in places, warm subsurface water ice, enough to maintain small pockets of liquid water deep underground, shielded from radiation, insulated from the cold, sustained by chemistry rather than sunlight. Scientists are careful about this. The evidence is indirect. The measurements do not yet reach deep enough to confirm what is or is not happening below the surface. But the possibility exists, held carefully, that somewhere beneath the cold and silent Martian plains, in the deep dark of the planet's interior, something warm may still be quietly happening. The universe tends to find the places where conditions allow, and then it tends to fill them. There is a thought that takes a moment to fully arrive, the way a deep sound arrives, felt before it is heard. Earth and Mars formed from the same raw material, the same disk of gas and dust swirling around the young sun, the same mixture of elements, the same physical and chemical processes operating under the same laws. They are not analogues or coincidental neighbors. They are, in the most literal geological sense, siblings. Earth and Mars were shaped by the same swirling disk of gas and dust, born from the same stellar nursery, emerging from the same long process of accretion and collision and settling that built all 4 rocky planets of the inner solar system. What separated them was not origin but outcome. Mars is smaller, farther from the Sun, with less internal heat and weaker gravity. These differences, modest in some ways, enormous in their consequences, set the two planets on diverging paths that have been separating for 4.5 billion years. We study Mars partly to understand Earth. We study Earth partly to understand Mars. They are the same experiment, run under slightly different conditions, and comparing them tells us things about planetary life and planetary death that neither one could teach us alone. You cannot fully understand your own story without knowing the story of the sibling that went a different way. From high above, a river system looks like a tree. A thick trunk of moving water branching into progressively thinner channels, spreading outward into a delta or narrowing upward into a source, the whole shape and expression of water finding the path of least resistance across a landscape over time. The pattern is instantly recognizable. Once you have seen it, you see it everywhere water has ever moved across land. The pattern of ancient valleys on Mars mirrors the branching pattern of river systems seen from orbit on Earth, a shape written by the same patient hand of water, following the same physical laws across two different worlds. These valley networks cover significant portions of the ancient southern highlands of Mars, best preserved in the oldest terrain, suggesting they formed during an earlier, warmer period in Martian history. They branch, they narrow toward their sources, they widen and deepen as they descend. They are, in every geometrical sense, rivers, or rather, they are what rivers leave behind when they are gone. The same mathematics that describes a river in the Amazon basin describes a dry valley on Mars. Water does not vary its logic from world to world. It finds the low ground the same way everywhere, patient and indifferent and entirely consistent, writing the same branching signature into the rock of any world that gives it the chance. There are streaks on the walls of certain Martian canyons and craters that have drawn more careful attention, more cautious debate, more repeated analysis than almost any other feature on the planet's surface. They are dark, they are narrow, they appear on steep slopes, they form in the warmer months and fade in the cold, and for years, the most straightforward explanation for their appearance was that something liquid was moving through the surface material and darkening it. Mars has a feature called recurring slope lineae, dark seasonal streaks on steep canyon walls that appear and fade with the Martian seasons, and scientists have been debating their origin carefully for over a decade. The liquid water hypothesis was compelling and widely discussed. More recent analysis has leaned toward dry granular flows, avalanches of dust and sand triggered by seasonal heating, as the more likely explanation. The debate has not been theatrical. It has been the slow, methodical work of comparing models to measurements, testing each hypothesis against new data as new data arrives, adjusting conclusions when the evidence requires it. Science does not always move toward more exciting answers. Sometimes it moves toward more careful ones, and there is a particular kind of integrity in that, in following the evidence wherever it leads, even when it leads somewhere quieter than you hoped. Picture a small tube of metal and glass, roughly the size and shape of a short walking stick, sitting on the surface of Mars inside a small, carefully designed rack attached to the belly of the Perseverance rover. Inside the tube, a core of Martian rock, drilled from an ancient lakebed, sealed and waiting. The Perseverance rover is right now collecting rock samples on Mars, sealing them in small metal tubes and leaving them in carefully chosen locations on the surface to be retrieved by a future mission that will, if current plans hold, bring them back to Earth for analysis in laboratories that can study them in ways no rover instrument ever could. Those sample tubes are sitting on the Martian surface right now, in the cold, in the dark of the Martian night. Each one a sealed message from a world we are only beginning to understand, addressed to scientists who have not yet been born, waiting for a spacecraft that has not yet launched. There is something in that image worth carrying gently into sleep. A small tube on a cold plain under alien stars, holding a piece of an ancient world, patient and unhurried, waiting for the future to come and collect it. There is a meteorite in a museum case somewhere, a dark, unremarkable-looking rock roughly the size of a potato that has traveled further than any human being in history. It formed on Mars 4 billion years ago. An asteroid struck the Martian surface with enough force to blast rock into space. That rock drifted through the solar system for millions of years before Earth's gravity caught it. It fell through our atmosphere and landed in Antarctica, where it lay undisturbed for 13,000 years. The oldest Martian meteorites found on Earth contain tiny structures that once sparked one of the most careful and consequential scientific debates in modern history, centered on whether those structures could possibly represent the fossilized remains of ancient microbial life. The consensus today leans toward a non-biological explanation for those structures: chemistry, not life. But the care with which the question was asked, the rigor with which it was investigated, the honesty with which uncertainty was acknowledged, all of that remains a model for how science handles a question whose answer would change everything. Some questions are important enough that the act of asking them carefully is itself a contribution, regardless of what the answer turns out to be. There is a particular quality to the light at noon, in a place where thin clouds diffuse the sun without blocking it entirely. Not bright, not dark, soft, directionless almost. The way light in a photographer's studio is made soft, coming from everywhere and nowhere at once, casting no sharp shadows, making everything look slightly gentler than it does in direct sunlight. That is roughly what noon looks like on Mars. Even light behaves differently on Mars. Dust permanently suspended in the thin atmosphere scatters sunlight in ways that make the middle of the day look more like a soft, overcast morning than a bright, clear afternoon on Earth. The dust is always there, a fine, pervasive haze of iron-rich particles that never fully settles, bending and diffusing the sunlight before it reaches the surface. Shadows on Mars are softer than shadows here. Edges are less sharp. The landscape has a quality of being gently lit from multiple directions at once, the dust acting as a natural diffuser spread across the entire sky. There is something almost tender in the way that planet receives its light, as if the atmosphere, thin as it is, still does what it can to soften the day for whatever might be living beneath it. Mars has a feature that has puzzled planetary scientists since it was first clearly observed from orbit, something that does not fit neatly into any simple story about the planet's history, something that sits at the center of ongoing investigation and genuine scientific uncertainty. The Martian surface is divided into two dramatically different hemispheres. The southern half is ancient, heavily cratered, and sits at a higher elevation. The northern half is smoother, younger looking, and sits several kilometers lower, as if it has been resurfaced by something vast that erased most of the impact record that the South still carries. Mars has a hemisphere divide that deeply puzzles scientists. The southern half ancient and cratered, the northern half smooth and low, as if reshaped by something enormous in the distant past. One hypothesis suggests a single, catastrophic impact early in the solar system's history struck the northern hemisphere with enough force to melt and resurface an area covering nearly 40% of the planet. Another suggests volcanic flooding. Another, the settling of sediment beneath an ancient northern ocean. No consensus has yet fully settled. The question remains open, sitting quietly in the Martian landscape, written in the difference between a cratered south and a smooth north, waiting for the measurement or the mission that will finally make it clear. The planet keeps its deepest secrets in the places that look, at first glance, simply like emptiness. There is a quality to disappearance that is different from destruction. A fire destroys, but a tide going out simply leaves. It withdraws slowly, steadily, following its own logic, taking with it everything that needed it to be present, leaving behind a landscape that remembers the shape of what was there without being able to bring it back. The magnetic field of Mars did not vanish in a catastrophe. It faded over hundreds of millions of years, and the planet's atmosphere followed it slowly outward, like a tide going out that never came back in. The process was gradual. The solar wind, a constant stream of charged particles flowing outward from the sun, slowly eroded the upper atmosphere once the magnetic shield weakened. Lighter gases escaped first. Heavier ones followed over longer timescales. The oceans began to thin and freeze as the atmosphere lost the ability to maintain the pressure and temperature they required. It took hundreds of millions of years. No catastrophe, no single moment of loss, just the slow, patient withdrawal of conditions that had made the planet something it could no longer be. In the end, what Mars lost was not destroyed. It was simply carried away, particle by particle, on the solar wind, into the dark. More than 50 missions have been launched toward Mars since the early 1960s. Flybys, orbiters, landers, rovers, each one a convergence of thousands of people's work, years of engineering, enormous sums of money, and the particular kind of institutional courage required to build something extraordinarily complex and then point it at a target hundreds of millions of kilometers away and let it go. Roughly half of those missions failed. Some failed at launch, some lost contact on the way, some crashed on arrival, some worked briefly and then went silent. The history of Mars exploration is as much a history of failure as of success, and that history is worth sitting with honestly, rather than glossing over. Humans have sent more than 50 missions toward Mars, and roughly half have failed, a number that speaks not to futility, but to the extraordinary difficulty of crossing the distance between two orbiting worlds with a machine that must work perfectly at the end of a journey that takes months and offers no possibility of repair. Every mission that succeeded did so against the background of the ones that did not. Every image sent back from the Martian surface carries, invisibly, the weight of all the attempts that never made it. Success in deep space is not the norm. It is the exception, earned carefully, held carefully, never taken for granted. Tonight, wherever you are, the sun will set or has already set. The sky will darken or has already darkened. And somewhere above the atmosphere, traveling its quiet orbital path around the sun at roughly the same distance from it as you are, Mars is receiving the last of its own day's sunlight. The same sun that set over you today will rise tomorrow over the Martian plains, a little smaller in the sky from that greater distance, its light a little cooler and more diffuse after traveling the extra distance, but the same star, the same ancient, middle-aged, yellow dwarf star that has been the central fact of this solar system for 4.5 billion years. This is a thing worth pausing on. You and Mars share a sun, not metaphorically, not in some abstract astronomical sense, but literally and specifically. The same fusion reactions, in the same ball of plasma, generate the energy that warms your skin and that, 40 minutes later after crossing the additional distance, reaches the Martian surface and casts those soft, diffuse shadows across the rust-colored rock. There is a family resemblance in that, a shared inheritance. The sun does not distinguish between the worlds it lights. It simply gives what it has, equally and without preference, to everything orbiting within its reach. There is sometimes a temptation, when thinking about other planets, to frame the interest as a kind of escape, a turning away from the difficulties of this world toward the imagined cleanness of somewhere else. But that framing misses something important about why Mars has captured human attention so persistently across so many centuries. Being curious about Mars is not escapism. It is one of the oldest human instincts. To look at a light in the sky and wonder if something could live there. To ask whether the conditions for life and warmth and water are unique to this one world, or written more broadly into the universe's possibilities. This curiosity is not frivolous. It is the same instinct that led to the first ocean crossings, to the mapping of continents, to the understanding of deep time and the structure of matter. It is the instinct that asks, what is over there? What does it mean? And what does it tell us about here? Mars asks us to think carefully about what makes a planet habitable. It asks us to consider what Earth has that Mars lost, and what we would need to preserve in order to keep it. It turns the gaze outward and brings back something that applies directly to the ground beneath your feet. Wondering about other worlds is one of the ways we learn to take care of this one. The frozen poles of Mars hold a quantity of water that is difficult to hold in the mind without a translation into something graspable. The South Polar ice cap alone, mostly water ice beneath a thin layer of frozen carbon dioxide, contains enough water that if it melted and spread evenly across the planet's surface, it would cover Mars in a shallow ocean. The frozen poles of Mars hold enough water ice that if melted, they could spread a shallow ocean across the entire planet's surface. This water is not gone. It has not escaped into space the way the atmosphere has slowly escaped. It is locked in place, preserved in the deep cold of the polar regions, sitting at the surface in some places and buried under sediment in others, waiting. Water is remarkably persistent. It changes form, moves between states, freezes and thaws and evaporates and condenses, but it does not simply disappear. The water that once flowed in Martian rivers is still on Mars. It is just very, very cold and very, very still. There is something quietly reassuring in that. Loss and disappearance are not always the same thing. Sometimes, things simply change their form and wait, in the cold and the dark, for the conditions that will let them be themselves again. Right now, somewhere in your body, a process is occurring that you will never feel and never think about and never need to direct in any way. Neurons are firing in patterns shaped by everything you have experienced today. Memories are being consolidated. The day is being quietly filed away. Your body is doing its most important work in the hours when you are least aware of it. Your sense of wonder right now is itself a physical thing. Neurons firing in specific patterns, chemistry shifting in measurable ways, the universe becoming briefly aware of itself through the particular configuration of matter that is you, lying here, thinking about a red planet in the dark. This is not a poetic elaboration. It is a neurological fact. Curiosity, awe, the feeling of smallness and connection that comes from contemplating deep space. These are real electrochemical events. They have a physical substrate. They happen in tissue shaped by millions of years of evolution, in a brain built, ultimately, from the same stardust as the planet you are thinking about. When you wonder about Mars, Mars is, in the most literal physical sense, part of the universe wondering about itself. You are not separate from what you are contemplating. You are an extension of it, briefly awake, briefly curious, briefly reaching across the distance with nothing but attention. Snow is a particular kind of silence. It falls without sound. It settles without announcement. It changes the texture of everything it touches, softening edges, muffling surfaces, making the world look briefly like a gentler version of itself. There is a reason people stop and watch it fall, even when they have seen it hundreds of times before. Snow falls on Mars too, though not in any form you would recognize if you held out your hand to catch it. Martian snow is made of frozen carbon dioxide, the same gas that makes sparkling water fizz and that your breath carries into cold air on winter mornings. It drifts down from high clouds in the polar regions during winter, tiny, delicate flakes of dry ice, settling onto a surface already deep in cold, adding their thin layer to the landscape before the season turns and they sublimate back into the air without ever becoming liquid. In some higher latitude regions, water, ice, snow falls too. Real frozen water descending through the thin Martian air in crystals so small they may evaporate before reaching the ground. A planet where snow falls is a planet with a water cycle, however faint, however incomplete. The sky gives something back to the ground. The ground receives it. Even on Mars, in its cold and thinned-out way, something like that exchange is still quietly happening. There is a crack in the surface of Mars so long and deep that if you stood at one end of it and shouted, the sound would die before traveling a fraction of the distance to the other end. Not because of any property of the canyon itself, but simply because of the scale, because the distance is too great for any signal, any voice, any human-made measure of length to carry easily. Valles Marineris began not as a canyon, but as a single seam, a fracture in the Martian crust that opened as the enormous weight and heat of the Tharsis volcanic plateau pushed the surrounding rock apart over billions of years. A crack in a planet, widening with the patience of geology, deepening through collapse and erosion, branching into subsidiary rifts and chaos terrain, until what began as a line became a system. The canyon system on Mars began as a crack, a single seam in the crust that opened and widened over billions of years into the largest canyon in the solar system. Its walls, in some sections, drop nearly 7 kilometers to the floor. Its width, in the broadest sections, exceeds the distance across several European countries placed end to end. It formed with no drama in any human sense of the word, only time and pressure, and the slow, inevitable release of forces that had been building for longer than complex life has existed on Earth. Some of the grandest things in the universe begin as nothing more than a line. When a river carries a stone, it does not carry it all at once. It rolls it along the bottom, lifts it briefly in stronger currents, sets it down again, picks it up again, moving it downstream in small, patient increments over years or centuries. All the while, the stone is changing. Its corners are wearing away. Its edges are softening. Its surface is being polished by contact with other stones in the current, by the friction of sand and gravel, and the constant patient pressure of moving water. The Curiosity rover found rounded pebbles on Mars in a region called Gale Crater, smooth and comfortable in the way that only water-tumbled stones become smooth and comfortable. Their size, their shape, their smoothness, all pointed to transport in a stream flowing at a walking pace, neither a raging torrent nor a sluggish trickle, but a calm, sustained river moving steadily across an ancient Martian landscape. Scientists have found rounded pebbles on Mars that can only have formed by tumbling in flowing water for a long time, the same patient process that rounds river stones in any streambed on Earth. You can pick up a smooth stone from a riverbank anywhere on this planet and hold in your hand a record of the same process that shaped those stones on Mars. The water is gone from Mars. The memory of it is not. Even as you rest right now, the Perseverance rover is sitting on the floor of Jezero Crater, a place that was almost certainly an ancient lake, fed by a river that flowed in from the west and deposited a delta of sediment at its edge over millions of years. The delta is still there, preserved in layered rock, its ancient structure visible from orbit and from the ground. The Perseverance rover is right now collecting rock samples on Mars, sealing them in small titanium tubes and setting them down at carefully chosen locations across the crater floor, building a cache of ancient Martian material for a future retrieval mission that will bring them back to Earth. Each sample tube is a sealed letter from an ancient world. Each one holds material that formed in conditions we are still working to understand. From a time when Mars was something other than what it is now, addressed to laboratories that will one day have the tools to read what is written in the chemistry and the mineralogy and the possible biology of those small, cold cores of rock. Those tubes are on Mars right now, in the dark, in a silence so complete that the word silence barely covers it, waiting, with no urgency whatsoever, for the future to arrive and read what they contain. There are places on Earth where volcanic eruptions have met water, where lava has flowed into the sea or across a wetland, where the collision of extreme heat and liquid water has produced landscapes of unusual chemistry, unusual minerals, and unusual biology. Hydrothermal pools in Yellowstone, for instance, their bright colors, the signatures of microorganisms living in conditions that would end most life instantly. On Mars, there is a feature called home plate, a low, layered, roughly circular structure in the Columbia Hills region that scientists believe was shaped by a volcanic explosion meeting wet, marshy ground in an ancient Martian past. The layering, the chemistry, the structure of the rock all suggest that hot volcanic material encountered water-saturated ground and erupted in a steam-driven explosion, leaving behind a shallow, bowl-like formation of altered rock. Scientists believe home plate was shaped by explosive volcanic activity meeting wet ground long ago, creating conditions that on Earth are associated with some of the most chemically rich and potentially habitable environments known. It is a small feature, understated, not dramatic in any visual sense, but it is exactly the kind of place where, on Earth, life tends to find a way. Small, sheltered, chemically active, warmed from below. The universe tends to fill the places where conditions allow. Whether it filled this one is a question we cannot yet answer. Methane should not be in the Martian atmosphere in any significant amount. The chemical reactions that occur in the Martian environment, the ultraviolet radiation, the oxidizing soil, the thin and reactive air, should break down any methane relatively quickly, within a few hundred years at most. If methane is present, something must be producing it continuously, or produced it recently enough that it has not yet been destroyed. Methane has been detected in the Martian atmosphere in small, fluctuating amounts, appearing in some seasons and in some locations and not others, in measurements taken both from orbit and from the surface by the Curiosity rover's instruments. The source is unknown. The leading possibilities are geological, methane released by the reaction of water with certain iron-bearing rocks in a process called serpentinization, or biological, methane produced as a metabolic byproduct of microbial life, the same way methane is produced by microbes in wetlands and in the digestive systems of animals on Earth. Scientists cannot yet distinguish between these possibilities with the measurements currently available. The methane is real. Its source is genuinely uncertain. That uncertainty is not a gap in knowledge to be embarrassed about. It is a specific, clearly defined question sitting in the Martian atmosphere, waiting for an instrument sensitive enough and specific enough to answer it. The first photograph taken on the surface of Mars was not a panorama. It was not a mountain or a canyon or a dramatic alien landscape. It was a footpad, the landing leg of the Viking 1 lander resting on the Martian soil, taken moments after touchdown on the 20th of July 1976, as engineers checked that the spacecraft had survived its descent. The first photograph ever taken on the surface of Mars was a simple image of a lander footpad on Martian soil, and it was enough to make engineers weep, not because of what it showed, but because of what it meant. A machine built by human hands had crossed hundreds of millions of kilometers of space and set itself down gently on another world. And the ground was there, exactly where the mathematics said it would be, solid and real beneath the landing leg. There is something in that image worth holding. A footpad on alien ground, the most ordinary-looking thing imaginable, metal resting on dirt. And yet it represented the end of a journey so long and so complex and so carefully planned that the people who built it could not fully believe it had worked until they saw the ground beneath it. The simplest images sometimes carry the most weight. Mars orbits the Sun in a path that is noticeably more elliptical than Earth's, meaning its distance from the Sun changes significantly over the course of a Martian year. At its closest, Mars receives considerably more solar energy than at its farthest, and this asymmetry between the two ends of the orbit creates seasons of unequal length and intensity. Mars orbits the Sun in a path more elliptical than Earth's, meaning its southern summers are short and fierce while its northern summers are long and mild, a seasonal asymmetry that shapes the entire climate pattern of the planet. The southern hemisphere has intense, brief summers followed by long, cold winters. The northern hemisphere has gentle, extended summers and shorter winters. The polar ice caps respond to this asymmetry differently. The southern cap more variable, the northern cap more stable. The dust storm season tends to peak when Mars is closest to the Sun and the southern hemisphere is in summer, the extra energy driving stronger winds and lifting more dust into the atmosphere. Every planet has its own version of this, its own orbital character, its own pattern of receiving and losing heat across its year. Earth's relatively circular orbit is one of the quieter gifts of this solar system, smoothing our seasons into something more balanced than they might otherwise be. Pick up any rock from the ground beneath your feet and hold it. Feel its weight, its temperature, slightly cooler than your hand, the texture of its surface against your palm. That rock, wherever you found it, is probably somewhere between a few million and a few 100 million years old, ancient by any human measure, young by the standards of the solar system. Some Martian rocks have been dated to over 4 billion years old, older than any rock currently sitting exposed on the surface of the Earth. Earth's oldest surface rocks have been consumed by plate tectonics, buried, melted, reformed. Their original chemistry transformed beyond recognition by the geological metabolism of a living planet. Mars kept its oldest rocks exactly where they formed, undisturbed, unmelted, sitting on the surface or just beneath it in the ancient southern highlands, holding a chemical record of the solar system's earliest solid period. When we study those rocks, we are reading a chapter of planetary history that Earth erased from its own record billions of years ago. The rock you hold from a garden path or a mountain trail is a youngster compared to what sits quietly on the Martian surface. Mars is, in this very specific sense, older than anything you can touch on Earth. Its patience with its own history is something that goes beyond any word we have for stillness. Imagine standing in a landscape that has not changed in any significant way for 2 billion years. No erosion softening the edges of impact craters. No vegetation slowly breaking down the rock. No rivers cutting new channels. No glaciers grinding across the highlands. Just the same surface, the same features, the same chemistry, sitting under the same thin sky, receiving the same pale sunlight, year after year, across a span of time so vast it contains the entire history of complex life on Earth, many times over. Mars has no plate tectonics, meaning its surface is a memory. Nothing recycled, nothing erased for billions of years. And in the ancient highlands, that memory runs so deep that features formed in the first billion years of the solar system's life are still clearly visible, undisturbed, waiting. There is a particular kind of preservation in stillness. The things that do not move do not change, and the things that do not change remember everything. Mars has been remembering for so long, and so faithfully, that we are only beginning to understand the depth of the archive it holds. Every feature on those ancient plains is a primary source, not a copy, not a summary, not a reconstruction. The original, sitting in the open, under an alien sky, waiting for something curious enough to come and read it. There is a quality to firelight at night that has nothing to do with warmth or illumination. A quality that is older than language, that reaches past the thinking mind into something quieter and more instinctive. The same quality belongs to starlight, to the light of a planet seen from a dark hillside on a clear night, steady and warm-colored among the cooler stars. On clear nights, Mars is visible to the naked eye, a faint reddish point of light that humans have watched and wondered about for as long as there have been humans to watch and wonder. Ancient Babylonians tracked its motion across the sky with such precision that their records, written on clay tablets, still survive and can still be read. They did not know it was a world. They did not know it had mountains and ice caps and ancient riverbeds and a buried lake and 2 small tumbling moons. They knew only that it moved differently from the stars, that it wandered, that it returned on a cycle, that it was red and steady and persistently there. Something in them reached toward it anyway. Something in them named it and watched it and recorded its movements with a care that suggests it mattered to them in ways they could not have fully articulated. That reaching did not require knowledge to be genuine. It only required attention, and attention, across all of human history, has always been the beginning of understanding. Bring a glass of water to the surface of Mars in your imagination. Set it down. Watch. The boiling and freezing happen almost simultaneously, the liquid lasting perhaps a fraction of a second before the low pressure and the cold conspire to end it. The water gone in a brief, strange moment that contains both of its phase transitions at once. The atmospheric pressure on Mars today is so thin that liquid water placed on the surface would boil and freeze almost simultaneously. The 2 processes competing in an instant, the water unable to exist in liquid form long enough to settle. And yet the rivers were there, the lakes were there, the ocean was there. For the water to have existed in liquid form for the thousands of years required to carve those valleys and round those pebbles and deposit those minerals, the atmosphere must have been fundamentally different, thick enough to maintain surface pressure above the threshold for liquid water, warm enough to keep it from freezing, stable enough to sustain those conditions across geological time. Something maintained those conditions once, something lost them. The gap between then and now is the central mystery of Mars, the question that all the orbiters and rovers and sample tubes are slowly, patiently, working toward answering. There is a particular honesty in not knowing. Not the honesty of admitting ignorance, which costs nothing, but the honesty of having looked carefully and thoroughly and arrived at the edge of what the current evidence allows, and stopping there and saying clearly, this is as far as we can go with what we have right now. Scientists are genuinely uncertain whether life ever arose on Mars, and that uncertainty is the product of extraordinary effort and extraordinary care, not of neglect. The question has been approached from every available angle. The chemistry has been analyzed. The mineralogy has been studied. The conditions have been modeled. The analogues on Earth have been examined. What the evidence shows is that Mars had the ingredients. It had the time. It had conditions that, on Earth, life has never failed to inhabit. What the evidence does not yet show is whether life actually appeared in those conditions on Mars, or whether the appearance of life requires something more than favorable conditions, something we have not yet identified, something that may have been present on Earth and absent on Mars for reasons we do not understand. That open question is one of the most important ones in science, and it belongs, at least partly, to the dark and quiet hours, to the kind of thinking that happens when the day is over and the mind is still and the questions can simply sit there, unresolved, without needing to be pushed toward an answer before they are ready. Somewhere in the night sky above you, if the geometry of the orbits is right and the sky is clear enough, there is a small blue-white point of light that you would not necessarily distinguish from a bright star without knowing where to look. From the surface of Mars, on a clear Martian night, that point of light is Earth. The night sky seen from Mars would include a small blue-white star, our Earth, steady and bright, a place where, right now, someone is lying quietly and wondering about Mars, while from Mars, Earth is just another light in a sky full of lights, beautiful and distant, and entirely unaware of being watched. This loop of mutual observation, Earth watching Mars, Mars indifferent and beautiful under its star-filled sky, carries something worth sitting with. We reach toward Mars with our instruments and our curiosity and our small metal rovers, and Mars holds its ground, ancient and patient, reflecting the same sunlight back at us that falls on our own upturned faces. The distance between the two worlds is real, and the connection is real too. Both things are true at once, and they do not contradict each other. Distance and connection are not opposites. They are two ways of describing the same relationship. The iron in your blood did not come from Earth. It came from a star that lived and burned, and at the end of its life collapsed and exploded, scattering the heavy elements it had spent millions of years forging in its core out into the space around it, where they drifted for millions more years before being caught up in the slow rotation of a new solar system forming around a new star. The iron in your blood is forged in stars, and so is the iron that oxidized over billions of years to give Mars its red color. You and that red planet share the same atomic ancestry, the same original source, the same long journey from the interior of a star through the chaos of a solar system's formation to the specific configurations of matter that you are now, and that Mars is now. The rust on Mars is your rust. The iron in that red dust is the iron in your veins, separated by origin only by chance, shaped into a planet on one path and into a heartbeat on another. You are not looking at something foreign when you look at Mars. You are looking at a cousin, made of the same stuff, shaped by the same forces, sitting at a different place in the same ancient story. Even as you rest right now, 3 spacecraft are orbiting Mars. They circle the planet in the dark, in the cold, on paths calculated to fractions of a millimeter by engineers, on a world they left behind months or years ago. They carry cameras and radar instruments and spectrometers and magnetometers, each one designed to answer a specific set of questions about a world that has been keeping its secrets for 4 billion years. Right now, 3 active spacecraft are orbiting Mars, and 2 rovers are sitting on its surface in the quiet Martian night, all of them gathering data, all of them sending it home across the dark at the speed of light, all of them expressions of a species that found a way to extend its curiosity beyond the boundaries of its own world. The rovers are parked. Their instruments are in low power mode. The Martian night is perhaps -80 degrees on the plains. Nothing is moving, except the slow orbital arcs of the spacecraft above and the faint drift of dust grains across the surface in the thin night wind. And from somewhere in that quiet, on a schedule no living thing on Mars maintains, a signal rises upward through the cold atmosphere and crosses the darkness toward a dish antenna pointed at the sky, and someone, somewhere on Earth, is waiting to receive it. There is a particular comfort in knowing that the same rules apply everywhere, that gravity does not have a different character on the far side of the galaxy. That light travels at the same speed through the void between stars as it does through the air above your head, that the chemistry of water is identical whether the water is in a glass on your nightstand or frozen in a polar cap on another world entirely. The same physical laws that shaped Mars are holding you gently in place right now. The gravity pressing you softly into whatever surface is beneath you, the electromagnetic forces holding the atoms of your body together, the thermodynamic processes keeping you warm, all of them identical in their fundamental nature to the forces that shaped a planet across the solar system. You do not need to travel to Mars to be touched by it. The connection is not metaphorical. It is written into the structure of reality itself, into the fact that the universe operates by a single consistent set of rules that apply without exception to everything within it, from the smallest particle to the largest structure, from a sleeping body on Earth to a dust storm on Mars, to a galaxy turning slowly in the dark. The laws do not change at the edge of the atmosphere. They do not change at the edge of the solar system. They are the same laws, everywhere, always, and you are held by them right now, as gently and as certainly as any planet orbiting any star. On a high desert plateau on Earth, far from any city, on a moonless night, the Milky Way does not look like a faint smudge. It looks like a river, a broad, luminous band of light arching overhead from horizon to horizon, so dense with stars that the eye cannot separate them, so bright that it casts a faint shadow if you hold your hand up against it. On the longest clear night on Mars, the Milky Way would look almost exactly as it does from a dark desert on Earth. The same river of stars arching over a different shore, the same ancient light arriving after the same journey across the same distances. The night sky is one of the things that would be familiar to a human standing on Mars for the first time. The constellations would be almost unchanged, the distances between stars so vast that moving from Earth to Mars shifts their apparent positions by only a tiny fraction of a degree. Orion would still be Orion. The Southern Cross would still hang where it always hangs. The Milky Way would still arch overhead. And in that familiar sky, there would be one new thing. A small blue-white point of light in a constellation, you know, brighter than any star nearby, steady and warm-colored in the cold Martian dark. Home, visible from somewhere else, for the first time in human history. The word recent in geology does not mean what it means in ordinary conversation. A geologically recent event might have occurred 10 million years ago. A young surface feature might have formed in the last 100 million years. Time in geology is denominated in units that make a human lifetime vanish into something smaller than a rounding error. With that calibration in mind, some scientists believe Mars may still be volcanically active in a very limited, very quiet, very intermittent way, with small eruptions possibly occurring even within the last few million years, which in geological terms is practically this morning. Some scientists believe Mars may still be volcanically active in a limited way, with small eruptions possible even in the geologically recent past, a possibility supported by surface features that appear younger than the surrounding terrain, and by the detection of gases in the atmosphere that could have a volcanic origin. If Mars still breathes volcanically, even faintly, even rarely, it is not the dead world it is sometimes called. It is a world in a long, slow cooling, still occasionally exhaling the last warmth of its interior into the thin, cold air, the way an ember breathes a thread of smoke long after the fire that made it has gone out. Not dead, merely quiet. And quietness is not the same thing as ending. The dust that covers Mars is not like the dust in your home, not like the dust on a country road, not like the volcanic ash that settles on towns near active mountains. It is finer than all of those. So fine that it behaves more like a gas than a solid when disturbed, swirling up into the atmosphere and staying there for months, carried by wind cut. The dust that covers Mars is so fine it stays suspended in the atmosphere for months after being lifted, dyeing the Martian sky with a permanent, soft blush of iron oxide that gives the air its characteristic butterscotch color and softens every shadow on the surface below. This dust has been accumulating and redistributing itself for billions of years. It coats every surface. It fills every low point. It settles on the solar panels of rovers and slowly dims them. It settles on everything that lands on Mars, beginning immediately, beginning gently. The planet slowly, softly claiming every visitor with its fine red powder. There is something almost welcoming in that. If you hold it gently, the planet does not remain indifferent to what arrives on its surface. It notices, it covers, it incorporates. It makes everything that lands there, in the slowest and most patient way, part of itself. Sound on Earth is so constant, so taken for granted, so thoroughly woven into the texture of experience, that the absence of it registers as something unusual and slightly unsettling. A room that is too quiet. A landscape after heavy snowfall, where the usual ambient sound is absorbed into the white. The thin air of Mars carries vibrations so faintly that a sound that would be loud on Earth arrives at the ear as barely a whisper. The Perseverance rover carries microphones, the first ever to record sound on another planet, and the recordings they have sent back are extraordinary in their ordinariness. The whir of the rover's own mechanisms, the faint rush of wind, the soft crunch of wheels on gravel, all of it quieter than the same sounds would be on Earth, muffled by the thin air into something distant and slightly dreamlike. Mars has no sound in the way you know it. What it has is the memory of sound, the structures that once carried the noise of flowing water, the valleys that once echoed with wind strong enough to carry a river's worth of water vapor, now silent, now still, the architecture of a soundscape that no longer exists preserved in the shape of the land. The rivers are gone. Their valleys remain. And a valley without a river is the most patient kind of silence there is. The question of whether Mars ever held life is not a question with a comfortable middle ground. Its answer, when we find it, will be one of two things, and either one will permanently alter how humanity understands its place in the universe. If Mars held life, even microbial life, even briefly, even in a single warm pocket of ancient water, then life is not unique to Earth. It arose independently on two planets in the same solar system, which means it almost certainly arose elsewhere too, on the billions of Earth-like worlds in our galaxy and the trillions beyond it. The universe would be, in the most consequential sense, full of life. The question of whether Mars ever held life is one of the few scientific questions whose answer, either way, would permanently change how humans understand their place in the universe. If Mars never held life despite having the right conditions for hundreds of millions of years, then life may be far rarer than we hope, and what happened on Earth may be something close to miraculous. Both answers are extraordinary. Both answers change everything. And we are, right now, in this specific period of human history, within reach of finding out which one is true. The instruments exist. The missions are planned. The answer may come within a generation. We are living in the last era of not knowing. There is a particular comfort in numbers that repeat, in rhythms that continue, in the knowledge that a process that has been happening for a very long time will still be happening after you have closed your eyes and let the day go. Even now, as the night settles around you, 3 spacecraft are circling Mars in the dark. 2 rovers sit on the surface. And somewhere in a laboratory on Earth, a team of scientists is analyzing data sent back from that world, looking at images of ancient rock and measuring the chemistry of a thin atmosphere and trying to understand what happened to a planet that once looked in some of its most essential qualities. Like this one, every mission to Mars carries a small piece of human attention across hundreds of millions of kilometers of cold vacuum, a quiet act of reaching that has continued, with brief gaps, since 1965. 60 years of sending something of ourselves toward a red light in the night sky, each mission building on the ones before it, each one answering a few questions and opening several more. The reaching does not feel urgent from here. It feels patient, steady, the way a long correspondence feels patient. Letters crossing a distance too great for conversation, arriving in their own time. Each one a small proof that the connection is still there. There is a perspective available to anyone willing to shift their scale of attention, a view from far enough away that the differences between planets become less significant than the similarities, a view from which Earth and Mars are simply two small rocky worlds circling the same middle-aged star in the same unremarkable corner of the same ordinary galaxy. The distance between wonder and despair is often just a shift in scale, and Mars, seen from far enough away, is simply a small, quiet neighbor in an enormous family, sharing the same sun, the same origin, the same fundamental physics, separated from Earth by a gap that light crosses in minutes, and that spacecraft cross in months, and that human beings will, within a generation or two, cross in person. From that distance, the differences between the two worlds, the thin air, the cold, the rust-colored dust, the absence of the magnetic shield that keeps this world habitable, are details. Real details, important details, but details nonetheless in the larger picture of two sibling worlds traveling their orbits around the same ancient star. From far enough away, everything looks like family. From far enough away, the solar system is a small and intimate place, and everything in it is closer than the dark that surrounds it. To understand what happened to Mars, you have to hold three things at once: a magnetic field, an atmosphere, and an ocean, and then watch them fall like dominoes in slow motion across hundreds of millions of years. The story of Mars's lost oceans is also the story of a magnetic field, because when the field died, the atmosphere began to leave, and when the atmosphere thinned below a critical threshold, the pressure dropped too low for liquid water to remain stable on the surface, and the oceans began to freeze and evaporate and slowly disappear into the rock and the ice and the thin, cold air. Each loss made the next one more certain. The field weakened, the solar wind stripped the atmosphere thinned, the temperature dropped, the water froze, the ice sublimated into a sky too thin to hold it, and Mars became, step by quiet step, the world it is now. Not through catastrophe, but through a cascade of slow consequences, each one the natural result of the one before it. What this means is that Mars was not destroyed. It was transformed. The water is still there, locked in ice. The atmosphere is still there, thin but present. The magnetic field left traces in the ancient magnetized rock of the southern highlands. Nothing was annihilated. Everything simply changed its form and settled into a new and much colder equilibrium. Loss and transformation are not always the same thing. Sometimes, what looks like an ending is simply a very long pause. There are forces holding you in place right now that you will never see or feel as distinct things. The gravity of the Earth pulling you gently toward its center. The electromagnetic repulsion between the atoms of your body and the atoms of whatever surface is beneath you. The force that makes solid things feel solid. The thermodynamic processes cycling energy through your cells, keeping you at a temperature 37 degrees above the air around you. You do not need to travel to Mars to be touched by it. The connection is not poetic. It is physical. The same gravitational law that keeps Mars in its orbit keeps you in your chair. The same nuclear physics that forged the iron in Martian dust forged the iron in your blood. The same thermodynamic principles that govern the Martian atmosphere govern the breath moving through your lungs right now. The universe did not make different rules for different places. It made one set of rules, consistent and universal, and everything that exists, from a grain of Martian dust to the largest galaxy in the observable universe, operates according to them without exception, without variation, without the possibility of opting out. You are not a visitor to the universe looking at it from outside. You are inside it, made of it, governed by it, as much a part of its physics as any planet or star. The distance between you and Mars is real. The connection is realer still. Stand outside on a clear night anywhere on Earth and look up for long enough, and you will see it. That slow, steady brightening of the sky toward the horizon where the sun set. Not sunrise, not moonrise, but the faint arch of the zodiacal light, sunlight reflected off dust particles spread along the plane of the solar system, a soft pyramid of light rising from the horizon in the direction the planets travel. That dust is everywhere between the planets, and some of it came from Mars. On the longest clear night on Mars, the sky would show the same zodiacal light, the same faint arch of reflected sunlight scattered by interplanetary dust, the same slow brightening toward the ecliptic, the same ancient light, the same ancient dust, the same geometry of a solar system still carrying the material of its own formation in the spaces between its worlds. The night sky belongs to no single planet. It is shared. The light that reaches your eyes on a clear evening, the planets, the zodiacal glow, the river of the Milky Way, is the same light that reaches a cold plain on Mars, an average of 11 light minutes later. The sky is a commons. Everything under it is, in some sense, a neighbor. There is something in the chemistry of ancient Martian rocks that speaks to the question of habitability more directly than any other single piece of evidence gathered so far. Not just the presence of water minerals, not just the rounded pebbles, not just the valley networks, but the specific chemistry of those water-formed minerals, their pH, their salt content, their temperature of formation, as recorded in their crystal structure. The chemistry of ancient Martian rocks in the oldest water-formed deposits suggests that the rivers and lakes of early Mars were not acidic wastelands, but relatively neutral, chemically mild environments, the kind of water that on Earth is associated with environments hospitable to microbial life. This matters because not all water is equally welcoming to life. Highly acidic water, highly salty water, water loaded with toxic compounds. These are challenging environments even for the hardy extremophile organisms that live at the edges of habitability on Earth. The ancient Martian water, as best as we can read it in the rock, was not like that. It was, in chemical terms, gentle. Gentle water, ancient sunlight, chemical energy from volcanic rock, time measured in hundreds of millions of years. These are the conditions under which life arose on Earth. Mars had all of them, once, for long enough. Whether something took the opportunity is the question we are still slowly working our way toward answering. The perchlorates in Martian soil were not what the scientists hoped to find. They are oxidizing compounds, toxic to most life as we know it, capable of destroying organic molecules that might otherwise preserve a record of ancient biology. When they were first identified by the Phoenix lander in 2008, they complicated the picture considerably. Minerals called perchlorates, found in Martian soil, are toxic to most life as we know it. Yet some bacteria on Earth thrive on them as an energy source, meaning even this apparent harshness does not rule out the possibility of life entirely. On Earth, certain microorganisms in arid, perchlorate-rich environments have evolved not merely to tolerate these compounds, but to use them metabolically, breaking them down and extracting energy from the process. If similar organisms existed on Mars, the perchlorates would not be a barrier to life but a resource. The universe has a tendency to fill available chemical niches. Every compound that seems at first like a barrier to life turns out, on Earth, to be something that some organism has found a way to eat. Whether Mars offered the same evolutionary opportunity, whether anything was there to take it, is a question that sits inside the broader question of Martian life. patient and specific, waiting for its own particular answer. There is a quality to the work of long-distance science that belongs to no other human endeavor. The waiting, measured not in minutes, but in months. The inability to go back and look again if you missed something. The knowledge that the instrument doing your looking is on another world, operating in conditions you can model but never fully predict, returning data across a distance so great that a question and its answer are separated by the time it takes light to cross the solar system. Every mission to Mars carries a small piece of human attention across hundreds of millions of kilometers. A quiet act of reaching that has gone on for 6 decades now, each mission adding to a cumulative body of knowledge that no single mission could have built alone. The scientists who designed the Viking landers in the 1970s could not have imagined the data that Perseverance is collecting today. The engineers who built Curiosity could not have anticipated every question its instruments would help answer. Each mission inherits the questions left open by the ones before it, adds new questions of its own, and passes both sets forward to the missions that will follow. It is a relay, stretching across decades, across generations, across the careers and lifetimes of thousands of people who never met each other, but who contributed to the same long, patient act of reaching toward a red light in the night sky and asking what it is. The bacteria that live in the harshest places on Earth, in the dry valleys of Antarctica where liquid water is essentially absent, in the hypersaline lakes where the salt concentration would kill most organisms in seconds, in the rock itself, living endolithic lives in the tiny spaces between mineral grains where a faint trace of moisture occasionally appears, these organisms have taught us that the boundary of habitability is not where we first assumed it was. Minerals called perchlorates, extreme cold, intense radiation, near total desiccation. Mars has all of these, and Earth has pockets where all of these conditions exist and life persists anyway. Stubbornly, quietly, invisibly, finding the chemistry that works and doing the chemistry that works, and asking nothing more of its environment than that it provide the minimum necessary to continue. The question is not whether Mars is habitable by human standards. It clearly is not. The question is whether it is habitable by the standards of the most minimal, most resilient, most chemically creative forms of life that exist on Earth. And by those standards, the answer is genuinely uncertain, not a polite uncertainty masking a likely no, but a real, investigated, carefully held uncertainty that the evidence has not yet resolved. The minimum necessary to continue is a smaller threshold than we once believed. Mars may or may not meet it. We are, right now, in the process of finding out. There are moments in science when an accumulation of careful, patient work suddenly makes something visible that was always there but never quite seen before. Not a discovery in the dramatic sense, not a single experiment or observation that changes everything overnight, but the slow arrival of clarity, the way a landscape becomes readable on a long drive as the light gradually improves. The science of Mars is still young. Most of what we know has been discovered in the last 30 years, meaning that in the largest sense, we are only just beginning, only just reaching the point where the questions are specific enough and the instruments precise enough to start distinguishing between the possibilities that the first era of exploration left open. The science of Mars is young, most of what we know discovered in the last 3 decades, meaning we are genuinely at the beginning of understanding a world that has been waiting to be understood for 4 billion years. What comes next will be built on what has already been found. The rounded pebbles, the clay minerals, the buried lake, the methane, the sample tube sitting in the cold on the crater floor. All of it will be part of what the next generation of scientists inherits, the foundation of a body of knowledge, still in its early chapters, still finding its shape, still in the beautiful, open-ended stage where every answer opens 3 new questions. That is where we are, right at the beginning of something that will outlast everyone currently working on it. There is a particular kind of quiet excitement in that, and it belongs entirely to the dark and the still and the slow hours of the night. There is a region in the Atacama Desert in Chile so dry that some weather stations there have never recorded rain. The soil is ancient, oxidized, perchlorate-rich, exposed to intense ultraviolet radiation under a sky with almost no moisture in it. For decades, scientists believed nothing could live there. Then they looked more carefully. They found microorganisms living not on the surface but just beneath it, in translucent salt crystals that let just enough light through while blocking the radiation, using the faint chemical energy available in that almost lifeless environment. The minimum conditions for life, every time we think we have defined them, turn out to be smaller than we thought. Minerals called perchlorates found in Martian soil are toxic to most life as we know it. Yet some bacteria on Earth not only survive perchlorate-rich environments but metabolize them for energy, meaning even the harshest aspects of Martian soil chemistry do not foreclose the question of life entirely. This does not mean life is on Mars. It means the barrier is lower than it first appeared. It means the universe has more room in it for living things than our initial estimates suggested. And it means that every time we revise the boundary of habitability downward, Mars comes a little further inside it. The universe, it seems, is more permissive than we are. There are two possible answers to the question of whether life ever arose on Mars, and both of them are extraordinary in ways that are worth holding quietly before sleep. The question of whether Mars ever held life is one of the few scientific questions whose answer, either way, would permanently change how humans understand their place in the universe. If life arose on Mars, then it arose independently on two neighboring planets in the same solar system, which means the emergence of life is not a miracle but a tendency, something the universe does when conditions allow, something that is almost certainly happening on countless worlds across the billions of galaxies we can observe. Life would not be a rare exception. It would be a feature. If life never arose on Mars, despite hundreds of millions of years of favorable conditions, then something beyond favorable conditions is required. Something we have not identified, something that may have been present on Earth by chance, or by a process we do not yet understand. Life would be rarer, perhaps vanishingly rare, perhaps unique. Both answers reshape everything. And we are the first generation of human beings with the tools and the presence on Mars to have a reasonable chance of finding out which answer is true. That is not a small thing to carry into the night. The ice at the Martian poles is layered the way the pages of a very old book are layered, each one distinct, each one a record of a season that passed before any human civilization existed, pressed together by the weight of time into something dense and patient and full of information that we are only now beginning to know how to read. Across billions of years of Martian silence, the planet has been holding its record in stone and ice, waiting without urgency for something curious enough to come and read it. There is no impatience in those layers, no urgency in those ancient riverbeds, no restlessness in the sample tubes sitting on the cold crater floor. Mars does not need to be understood. It has been fine without understanding for 4 billion years. It will be fine for 4 billion more. What changes when we understand it is not Mars. What changes is us. Every piece of Mars we read, every mineral analyzed, every ancient shoreline mapped, every methane measurement taken, adds something to the picture of what a planet is, what it needs, what it loses, what it keeps. And that picture, slowly, carefully assembled, is a picture of where we came from and what we are and how rare or how common our particular arrangement of conditions might be. Mars is patient. The understanding belongs entirely to us. There is a quality to sleep that resembles, in its own small way, the long stillness of geological time. The body slows. The mind releases its grip on the day. The temperature drops slightly. The breathing deepens and spaces out. The self becomes, for a few hours, something quieter and less insistent than it is during the day, something closer to the deep background hum of a living system simply continuing. Even in sleep, your body is doing something extraordinary, repairing tissue, consolidating memory, cycling through the stages of rest that evolution has found necessary for a brain this complex to function well. Not unlike the way Mars stores your sleep tonight is a kind of archive. The day you just lived is being filed away in the same patient, layered way that Mars files its seasons. You will not remember the filing. You will simply wake with the result. The day integrated, the memories settled, the self slightly more continuous than it was before. Rest is not the absence of process. It is a different kind of process, one that happens in the quiet, out of sight, while the surface of things lies still. The two planets have been traveling their orbits in silence for over 4 billion years. They formed from the same material, received the same sunlight, followed the same physical laws, and arrived at entirely different outcomes. Through differences so subtle in origin and so enormous in consequence that the gap between them feels, from the inside of one of them, like the difference between everything and nothing. The two planets have been drifting in their orbits for over 4 billion years, each shaped by the same sun, each carrying water in some form, each following the same quiet laws, one of them becoming a world of oceans and forests and sleeping creatures, the other becoming a cold and ancient archive of what that world might have been. There is no tragedy in that divergence, unless you need there to be one. Two outcomes from the same beginning, each one complete in its own way, each one teaching the other something it could not have learned alone. Earth teaches us what Mars could have been. Mars teaches us what Earth has managed to hold on to. Together, they tell a story about the conditions for life that neither one could tell alone, and that story is not finished. It is still being written, slowly, carefully, by instruments on distant planes and scientists at late-night desks, and by whatever the universe has arranged to happen next, in its own time, at its own pace, without urgency. In a distant future, measured not in centuries but in millions of years, the axial tilt of Mars will shift again toward its higher range. The poles will receive more direct sunlight. The ice will begin to sublimate. The atmosphere will briefly thicken, and the conditions that once allowed liquid water to exist on the surface may return, partially, temporarily, for a span of thousands of years, before the tilt shifts back and the cold returns. Mars will not always be cold. Its axial tilt shifts on a cycle of millions of years, and in a distant future, its poles may melt, and its skies may briefly thicken again. A temporary reprieve in the long cooling of a planet that has been slowly losing its warmth for billions of years. Nothing in the solar system is permanently fixed. The planets breathe on timescales too long for any single generation to witness. But they breathe. Mars has been through warmer periods and colder ones, through times of greater volcanic activity and times of near-total geological silence, through the full and the empty of its own long cycle. What feels like a final state is never quite final. The universe does not deal in permanent endings. It deals in conditions. And conditions, given enough time, always change. When you look up at the night sky and feel something, that quiet expansion in the chest, that sense of being small and held at once, that particular mixture of awe and belonging that comes from standing beneath a lot of stars, you are participating in something that runs unbroken from the first human beings who stood upright and looked up to you, right now, in this room. What you feel when you look up at a night sky is not a small thing. It is a continuity that runs from the first humans who watched these lights to you, right now, in this room, lying still in the dark, carrying 4 billion years of biological history in every cell, wondering about a red planet that your ancestors watched without knowing what it was. That wondering did not begin with telescopes. It did not begin with rovers or orbiters or spectrometers or sample tubes. It began with attention, with the simple, ancient, irresistible act of noticing a light in the sky and feeling that it mattered, that it meant something, that it was worth looking at carefully and returning to look at again. You are the current expression of that attention, the latest in a line so long it disappears into the dark of deep time, and the line continues through you, forward into a future where the questions you are carrying tonight will be answered by people who have not yet been born. There is a mirror quality to Mars that becomes clearer the longer you look at it. A planet that had liquid water, that had a thick enough atmosphere to maintain it, that had chemistry mild enough to welcome life, that had time, enormous, patient time, for something to begin. The mystery of Mars is ultimately a mirror, a planet that had what Earth has, that lost it, that still holds the traces of it in its ice and its minerals and its ancient valleys, asking us quietly what it means to hold on, what it takes to keep the conditions for life stable across the deep time that life requires to develop and diversify, and eventually look back at the sky and ask questions. Earth has held on. So far, it has kept its magnetic field, its thick atmosphere, its liquid oceans, its moderate temperatures, its water cycling continuously between sky and ground and sea. It has kept, for 4 billion years, the conditions that Mars lost. That is not guaranteed to continue indefinitely. But it has continued long enough for us to be here, asking the question, lying in the dark, wondering about a neighbor that lost what we still have. The wondering is itself a form of gratitude, even if we do not always name it that. There are questions that belong to the night in a way they do not belong to the day. Questions that require the quiet, that expand into the space left by the absence of ordinary noise and ordinary urgency, that need the dark to be fully themselves. Every answer Mars has given us has come slowly, carefully, through years of patient science, and there is something genuinely restful in knowing that not all questions demand an immediate answer, that some of the most important questions in human history are being held carefully by thoughtful people who are willing to take the time to get them right. The rovers move slowly. The orbiters circle patiently. The sample tubes wait in the cold. The scientists analyze and reanalyze and publish carefully worded papers that advance the understanding by a small but real amount. And the understanding grows, year by year, mission by mission, in the slow and steady way that durable knowledge always grows. You can rest inside that patience. You do not need to hold the questions tonight. They will be there tomorrow. The people working on them will still be working on them. The planet will still be there, rust-colored and ancient and full of its quiet record, exactly as patient as it has always been. The universe has no urgency. It never has. It proceeds at its own pace, in its own time, without reference to any schedule any living thing has ever kept. The universe has no urgency. Mars has waited 4 billion years to be understood. The answers it holds have been sitting in its rock and its ice and its thin, cold atmosphere for longer than complex life has existed anywhere we know of. They will still be there tomorrow. They will still be there in 100 years. They are not going anywhere. And neither are you. Tonight, you are exactly where you are supposed to be. In the dark. In the quiet. Small and held and connected to everything. Made of the same stardust as the planet you have been thinking about. Governed by the same laws. Circling the same ancient star. The questions are good ones. The people asking them are careful and patient and honest. The universe is vast and old, and full of things we have not yet learned to read. And you can rest now. All of it will continue quietly without you for a few hours. The planets in their orbits, the rovers in their silence, the sample tubes in their cold, the Milky Way turning slowly overhead. Everything that matters is still happening. You do not need to watch it. Let the weight of your body settle a little more deeply into whatever is beneath you. Let the thoughts about distance and time and red planets and ancient rivers grow softer at their edges, the way a landscape softens in the last light before dark. Somewhere right now, a faint signal is crossing the space between two worlds, carrying a measurement, a photograph, a record of a temperature or a chemistry or a wind direction on a plane where nothing living has ever stood and watched the sun go down. And somewhere right now, a person is receiving that signal, reading it carefully, adding it to everything else that has been learned about a world that once had rivers, and writing it down. The work continues. The patience continues. The reaching continues. Quietly, in the dark, while everything that needs to rest is resting. Mars is out there right now, rust-colored and still. Its two small moons crossing its sky in the cold dark. Its ancient valleys lying open under the stars. Its sample tubes waiting. Its buried lake sitting in its deep silence beneath the southern ice. It is not going anywhere. It will be there when you wake. It will be there long after every question we are currently asking has been answered and replaced by newer, better questions. You have been carrying a lot of the universe in your mind tonight. You can set it down now, gently, the way you would set down something old and valuable that you have been holding for a long time. The stars are still there. The planet is still there. The ancient story is still unfolding, slowly, in its own vast and unhurried time. You can close your eyes now. Let the darkness be soft. Let the quiet be complete. Let whatever is still turning in your mind turn more slowly, and then more slowly still, until it is as quiet as a plane on Mars in the long Martian night, under a sky full of stars, with nothing moving but a little dust in the cold wind and the slow arc of a small dark moon crossing toward the horizon. I hope you sleep well and dream softly. Good night.